Schönen guten Tag zur zweiten Sitzung im Exastream. Ich sehe, viele waren gestern schon da, die heute auch da sind. Wir starten heute mit einem Vortrag aus dem Oracle Product Management. Deshalb werde ich gleich ins Englische wechseln. Und let us welcome for a presentation from Gavin Parish. Gavin is Product Manager in the Exadata team, but I think it's more efficient if he is introducing himself. So Gavin, it's your turn.
Thank you. Okay, so hi everyone. Good evening. It's good morning here, but that's all right. Yeah, my name's Gavin Parish. I work for the Exadata product management team here in Redwood Shores, California. Today, I'm here virtually to talk through a few things with you. If you have questions or want to go off topic or chat about stuff, I've got the little screen up to show me. We're just going to go through some of what's new and a little bit of what's coming. I know this session's being recorded, so I can't really talk off the record here. Next time we're in the same room, we probably can talk a little more freely. But so yeah, we'll go through a few things on what's coming up. But yeah, okay. So where are we? Let me just get this slide over and done with. I do have a few statements. Exadata, it's something that's been around for quite a while, and I joined product management. It's about 18 months ago now, and since joining, it's been an interesting experience seeing an engineering team so dedicated, so focused on a particular product. And this slide that you're seeing here is kind of a vision statement of theirs, and it's something that I've noticed is very much forefront in everything they do. It's three main areas. It's finding the ideal hardware to run a database, not a generic platform, not a virtualization platform, a database platform. So finding that hardware and working on getting the best hardware to run the Oracle database. Smart system software, this is where all of the features and benefits come in, and really where the hardware just comes to the front, because we're able to own the whole stack and therefore make tweaks within the software to take advantage of that hardware. So the system software is an amazing piece of this whole platform, and really is the glue. And the last bit, automated management. I actually think that this at the beginning might not have been such a focus, but is really coming through, especially in more recent years, with the idea of cloud and automation and autonomous database. Yeah, is a big driver for this. So this is the three kind of pillars of the vision for the Exadata team. We've been around since 2008 and seen a lot of major companies, deploying their critical systems on this platform, and it's quite incredible seeing the breadth and depth of Exadata's use across the globe. We're in every geography, every industry. You can see it's a spattering of names here. You probably notice, quite a few. You know who they are, and it's not just a particular type of workload. We have petabyte data warehouses. We've got online financial transaction systems. We've got obviously business applications like SAP and Oracle Fusion, things like that. And more recently, consolidation, as customers realize the benefits of running on Exadata, being able to consolidate not just tier 1 but tier 2 application workloads onto the Exadata. So yeah, we're seeing some some amazing use cases and some really great work that's going on and running the core of the global economy kind of thing. So yeah, it's very exciting to see, and I get to talk with people like you about what your use case is, what you're looking for, and what you're up to and what you need. As a product manager, I need to understand your use case. I need to understand where you're wanting to take your company and what you need for future, because that's a way we can make Exadata better is by understanding what's required and working towards that goal with you. So back in September last year at Open World, we released the X8M generation of Exadata. It was the second release of 2019. We initially announced the X8 back in April, and the biggest piece of that was the Cascade Lake CPUs, the mitigation of Spectre meltdown vulnerabilities in silicon rather than in software, and a few enhancements. We had the extended storage come out in April in the X8, and the storage servers themselves got a fairly significant boost in performance with the 16-core CPU. But in September, I've got them highlighted in red. There were 3 major changes with the Exadata platform, and that's the conversion to RoCE, RDMA over Converged Ethernet. InfiniBand has been around a very long time on the platform, but as I mentioned in the first slide, the vision was to find the ideal database hardware. And every year, every time something new comes up, the engineering team are looking at it. They're identifying which is a good technology to pick up, which is the right technology to pick up, and when to pick it up. And RoCE was one of those things that we've been monitoring for years. We've been actually working on this platform for about 4.5 years. So now was the time that the move happened, and the platform was the RoCE network protocol and technology was stable enough for us to look at and work on. We've worked with our vendors, Cisco in this particular instance, as a technology and as a solution to make sure that it was the correct decision to make. So the other piece, and I'll go through RoCE in just a little bit of detail in a second. I'm trying not to do a deep dive of technology today. We're just going to skim across the top. The other piece of new technology that we bring in with X8M in September was persistent memory. So it's a new tier of storage, and I'll go through this in a little bit of detail coming up. And the last piece that we decided to move to as part of the RoCE move and persistent memory inclusion was KVM. So moving from a Xen hypervisor on the InfiniBand across to KVM as that virtual platform. So they're the kind of the 3 major areas that were looked at for X8M generation. So that was 6 months between our InfiniBand X8 and our RoCE-based X8M. So the 2 releases, which were pretty exciting, and as my first year in product management, I had a fair bit to do to work on these. So I mentioned RoCE, RDMA over Converged Ethernet. So InfiniBand was really the only viable platform back in 2008. They obviously looked at Ethernet. Ethernet's the standard. Everybody uses it. Everybody knows it. But it's really bad when it comes to high performance networking. InfiniBand was the only one that ran RDMA capable networks. It was lossless. It was it had all the benefits that you need for running a high performance network. But Ethernet is now caught up. You know, the protocols of Rocky are actually run by the same group of companies as InfiniBand. It's the same standard. It's IBTA that run the standard. So they know about, you know, running high performance networks. They understand the protocols required for that. And being able to run on Ethernet is one of those features that came through for Rocky. We're actually using Rocky V2 if you want to look it up. It's the industry standard. It's Rocky but across subnets. So that's the V2 bit. Yeah, so moving to an industry standard, we thought at this particular point in time, you know, weighing up the differences between InfiniBand and Rocky and looking at the future roadmap. You know, they both have 100, 200, 400 gig on the roadmap. So what are the benefits of staying where we are, moving to Rocky, and seeing, you know, and weighing out what was required. Now is the time, and they made the move, and Rocky's been very successful since that September. We've got, you know, customers deploying it as their standards, which is great. And if you have a look at the little map on the left, it's kind of meant to be the OSI stack, starting from the bottom, the hardware, moving up to network and application. You'll notice at the application level, you know, that layer 5, 6, 7, it's actually the same. So, you know, the transport layer is still InfiniBand. If you dig into it, there's still InfiniBand verbs being used by the upper stack. It's just moving across an IP-based network on Ethernet rather than the InfiniBand network across InfiniBand. So if you really think about that, if you've got, you know, your grid infrastructure, your rack, your cache fusion, all of the components that are sitting in the upper stack, they're all using the identical code, the same code. It's just that transport layer, just under the transport layer that's been changed. It means that we can support all of the existing optimizations that we've had and been working on for the last, you know, 10, 15 years for Exadata. All of those features are moved across. We haven't had to rewrite any of it. We don't have to start from scratch. You know, we're starting with a 10-year, 15 years of engineering head start. So it really means that, you know, Rocky is not a brand new platform that we're having to vet and verify and make sure it's that same InfiniBand based, same kind of benefits of running and all of those optimizations that we've had, you know, the cache fusion, the direct IO, things like that, has just been moved across. And all of those optimizations are there and available and running. But we see some, you know, some benefits, well, a few benefits, but that 2.5 times faster. So being able to run on a 100 gig network as opposed to that 40 gig network on InfiniBand. We're still getting the 0 packet loss messaging. That's critical. So being able to not have to wait for that typical Ethernet, you know, did the receiver get the block? Do I need to retransmit? Things like that. So being able to have that 0 packet loss. And the other one, the prioritization. So being able to have priority lanes, basically, of this is a high priority packet that I need to send. Get that faster than my backups, for example, my RMAN or whatever, the bulk amount of packets. So being able to prioritize was the other big piece of the Rocky platform. We had that in InfiniBand, so therefore we needed that on the Rocky platform, and all of those same you know, benefits and features were available for that Rocky network. So that's kind of why now, why the move was there. As I mentioned, you know, we've been working with Cisco for many years. It was 4.5, 5 years of work with them, making sure that the platform was ready, the network stack was ready. We used their switches in that Rocky network, and being able to pick up industry standard protocols. Not having to build our own, not have to roll our own code for that. I think is really going to help the future, and being able to move quickly with the industry and what is coming up. Yeah, so because Rocky as that standard, as an industry standard, it's actually maintained upstream, so we don't have to worry about what firmware and what we need to do to make Rocky work. It's coming through from upstream, so that's really good. So that's Rocky. We've got quite a bit of collateral out there about going further into details on that. So if you want to look at that, or if you can't find it, let me know. I'll point you in the right direction there. The other piece that I mentioned was persistent memory. So it's a brand new storage tier. It's a brand new piece of silicon. We use the Intel DCP-PMEM persistent memory. It's, as you can see in that little diagram, top right, it's a DIMM format is the one that we're using. And what's exactly the way it sounds. It's persistent and it's memory. So unlike DRAM, it persists. It's not ephemeral. So if a power failure happens, if a reboot happens, it keeps the data on board. But it's written at memory speed. So it's actually in a DIMM slot. It's on that memory bus. So the performance is much better than as soon as you step off into that storage and PCIe and down in the storage network. So performance is brilliant. And you'll see in the diagram on the right, as you get closer to the CPU in terms of storage, it gets much more expensive. Starting at the bottom, you've got your bulk amount, your bulk storage, terabytes of data for not much price. But as you go into flash, you're paying more for your gigabyte, and then persistent memory kind of sits in between DRAM and flash. So it was a perfect position to insert that next tier of storage. And if you've worked with Exadata for any amount of time, you'll notice that the engineering team are very good at tiering of storage and being able to move hot blocks into faster areas. And so what they've done is basically build that identical flash cache layer into persistent memory. So now we basically treat flash as a warm cache, and persistent memory is where the hottest of the hot data sits. So yeah, it's really the system software that builds that. We have the persistent memory is deployed in app direct mode. So there's a few different modes, and it's all documented out there, whether it's XMEM or app direct. Being able to change our code to make use of that persistent memory as persistent memory, and not just an addition to DRAM was key. And that's as I mentioned at the beginning, the software is the piece that makes all this work. So that's persistent memory. It's been exciting to see a new tier of storage come in. It's not often that you see an architectural change in a product, and being able to insert that persistent memory is a great example of the benefits of owning that full stack and being able to work with the database team to take advantage of a piece of hardware that is coming in, an architectural piece of storage that's coming in. Being able to work with our vendor, in this case it was Intel. We've been working with them for years on this technology, and being able to go back to them with use cases and the understanding and working with their engineering team to deploy this in the best possible way. talking with the engineering team, we could have deployed this like 2 years ago when persistent memory first came out, but that wouldn't have been architecturally perfect, and it wouldn't have been the ideal, place to insert persistent memory. If you have a look at some of the other vendors and how they've implemented persistent memory, it's not taking advantage of what it is, that that memory channel, that high-speed memory bus insertion of that persistent memory. So, going back and working with Intel and working with our database team to make sure that it was the perfect position and the best possible outcome of using that persistent memory. So that was the that kind of second bullet in terms of X8M and what we bring and what we've released in September. The third part was KVM, as I mentioned. Everybody, if you've been around virtualization for any period of time, you know that there's Xen and KVM are the two big virtualization platforms. And on InfiniBand, we have Xen, and we'll continue having Xen on the InfiniBand network. We made changes in the Xen, the hypervisor, and to take advantage of InfiniBand and making sure that it was working correctly. KVM runs on Ethernet. There's obviously tweaks that we've done and to make sure that we're still using SRIOV to get to the hardware, and bypassing the hypervisor, things like that. But in terms of rolling your own code, we no longer have to do that. KVM it's the standard out there. More and more people are using it. So a lot of that kind of industry knowledge and the ability to understand what's going on, we get those kind of benefits. It's running on Ethernet. Rocky is just an enhanced Ethernet. So we get all of those benefits of moving to that. And we bring across things like trusted partitioning, to make sure that from a customer perspective, there's no difference. You see the benefits of the performance and the understanding of how KVM works, but you get the additional benefits of knowing that from a virtualization point of view, running those workloads on Exadata, we still get those same high performance access to hardware and things like that. And really from an end user point of view, there's no difference. You're still deploying using the same tools. You're still backing up using the same tools. It really should just be it is installed by default. You just create your virtual machines and you run your database workload, because what we're all focused on is running that database workload. So a few of the benefits of running KVM on Rocky. We have been able to increase the amount of storage, the memory that we can run our virtual guests with. So up from 720 on InfiniBand, we can now get to 1.3 terabytes per virtual machine or total across the number of virtual machines. We get a faster client network latency, or lower client network latency. We're getting 12 virtual machines. So the testing team and the performance team within the Exadata engineering team have been working on making sure that the stability is there. There's a reason we kind of mandate 8 virtual machines on the IB technology. Making sure that these virtual machines are rock solid and the performance is there, but the stability is the main thing. So working on the KVM, they really pushed it hard, making sure that 12 virtual machines was stable, it was resilient. We could still do everything we needed to do, but making sure that it would run successfully and ensuring that everything was was perfect for running that. So that's kind of why we put limits on. You know, if you have a look at the number of cores we have and the number of the amount of memory that we have, you know, from a pure virtualization point of view, you'd be looking at that and going, well, of course you can run more virtual machines, but we put limits on to make sure that it's stable. You know, we're not focused on virtualization, we're focused on the database. We're focused on being able to run that Oracle database workload successfully with as minimal risk as possible. And, you know, we do a lot of work in-house and obviously a lot of testing to make sure that everything that we push out is fully tested and vetted and supported, and you know, ensures that that Oracle database workload does not get impacted. So it's kind of, and you know, kind of why we've come up with 12 on KVM. And a faster install procedure. If knowing Zen and KVM, Zen is actually a brand new OS that's deployed. And so on InfiniBand, it was deployed and reinstalled. But with KVM, it's an extension to the kernel. So there's no second OS, there's no reinstall. So a faster install process. Okay, so that kind of all gets us through X8M, and you know, the outcome of Rocky, the outcome of persistent memory, is a huge increase in performance, over 2.5 times faster than what we had in NX8. So that was 16 million IOPS. It's actually 16.5, but when Larry announced it, he didn't want to just count numbers, so he said, oh, 16 will do. But a huge increase in performance. The latency, this is really where persistent memory comes in. Being on that memory bus means that the latency between you know, database and storage is cut more than 10 times faster. You know, back on InfiniBand, it was up at 200 and 250 microseconds. With Rocky hitting that persistent memory layer, it's less than 19 microseconds, and that 19 microseconds is actually hitting it's doing 3 million IOPS as part of that. So huge performance gains there. Yeah, the use of persistent memory in accelerating transactions. So not just reading, but we have our log writes running faster on persistent memory. I've got some deep dives out there. If you have any questions on how persistent memory works within Exadata, let me know, or you know, look at the YouTube channel or look at our office hours. There's plenty of discussions around that. And like Exadata always has been, that the performance scales as more racks. So these numbers are for a single rack, and performance scales as we add more racks to it. So some of the benefits, obviously, you know, it's great getting 16 million in a single rack, but not every customer needs that kind of performance. But it means that our kind of lower sized, you know, quarter rack, elastic rack, even down at our 8th rack, our smallest platform gets those kind of performance benefits. So you can do more with less, and that's really one of from a product management point of view, it's one of those ideas that if we can give you a bigger bang for buck kind of thing, it means that you can continue working with the same budget. You've still got, you know, you've got an IT budget and IT workload that you need to take care of as you focus on your company. Unless you're an IT company, you know, that's not your bread and butter. You want to focus on your business. So let's get you a platform that that is as best as we can get for the money that we can get it for, and allow you to focus on your core business. So running OLTP workloads, if we can run that faster for you, then I believe we've won as a from a product point of view. we are, growing those benefits for you. Data warehousing and mixed workloads, being able to consolidate, being able to have your data warehouse and your OLTP in the same system, and just increasing that value for money for what Exadata is. Adding that persistent memory actually frees up the CPU for bigger workloads. So if PMEM is there, interacting for that OLTP system, it means that the storage server can run your data warehousing workloads. Having that new network, the Rocky network coming in, and the 100 gig speeds means that we can move data around faster. It means that we can get better performance. It means that we can get a better benefit for you for the X8M. So some big picture stuff. We already have I believe the best platform for database. Adding in persistent memory, moving across to Rocky, really accelerates our ability to capture as many different use cases as you need us to capture. And so now we're looking at kind of a new class of application, higher frequency trades, real-time fraud detection, IoT. That's going to be huge as the global economy and workload moves from the old style, the transactional processing across to new workloads like IoT. Everything's enabled, everything's connected. Doing modeling within the database, AI, machine learning in the database. We're able to capture a lot of those new workload types because of the performance benefits that we can bring in. And the big one at the bottom, no application changes. So being able to add all of these new features and persistent memory and Rocky without actually needing any application changes, without you needing to sit down and figure out how to integrate this yourself. We've done all the heavy lifting, we've done all the work for you. So all you need to do is just move your database workload across and you get those benefits. So that's kind of the big picture of where we are with the Rocky release of X8M. I've been talking for half an hour solid and I'm not seeing any questions, so I'm just going to keep going. If you have questions, please let me know. But until I see something pop up, I'll just keep talking. It is really kind of weird not being able to interact with you, not being able to see your face to see if I've put you all to sleep or if you're actually still sitting there. And actually, while I'm here, let's do this. If you've got, if you ever think about, I'm going to keep talking, but if you can think about one thing you like about Exadata, one thing you don't like about Exadata, and one thing that you want to know more about with Exadata, so 3 things. You can either put in a question. You've got my contact details. You can send me an email or hit me up on Twitter or LinkedIn or wherever. But if you can tell me those 3 things, one thing you like, you don't like, and one thing you want to know more about, it means that, yeah, we can kind of target some more things. We've got office hours that we work on. We've got blogs that we can write. We've got white papers that we can write. I need to know what kind of areas that you want to look at and focus on. Yeah, so just let me know. This is being a conference. I would normally be asking you in person, over a beer or coffee or whatever. So virtual, let's do this. Yeah.
There are 2 questions. One concerning Rocky. Concerning the speed of Rocky, is Rocky really 2.5 faster than IB, and it's really faster in form of less latency, or only more bandwidth?
So from a pure speed speed point of view, InfiniBand was 40 gigabit per second. Rocky is 100 gigabit per second, so that is the 2.5. You then look at, well, okay, InfiniBand was lossless. It had all those benefits of of that high performance network. From a Rocky perspective, well, that's exactly what Rocky is. You kind of need to park your idea of what Ethernet is and bring in what converged Ethernet is, and on top of that, the Rocky standard. And yeah, it actually is that much faster. So yeah, I mean, the 2.5 is a 40 gig to 100 gig 2.5. But all of those underlying benefits of InfiniBand and the lossless pieces has moved across to Rocky. So yes. Sorry, what was the second half of that question, Ryan?
Only a question of bandwidth, the speed of the
okay.
Rocky.
Yeah. All right.
Sorry.
Question?
Yeah, there's one question concerning what is coming new. You told us a lot of known stuff, but the chapter what is coming new is missing.
It is, yes, and that's kind of where we're stuck, being virtual and this being recorded. I can't talk futures too much. If you look at we'll get to a bit of that. How about I carry on a little bit more, and then we'll see where we get to. Do people want to hear about cloud? I suppose is the other piece of this. Rocky Exadata is not just an on-prem product. We have a lot happening on the cloud with our Exadata cloud service. Cloud at Customer has had some great features come in. Let me just flick through to that. Being able to move. Whoops, that's a build out. Kind of Exadata is everywhere that we think you need it. So being able to run in the cloud as part of the Exadata cloud service is a huge piece of where we see customers going, and being able to pick up database workload in that cloud. So we've had some new things happening in Exadata cloud service. They have moved to the X8 generation of Exadata. Cloud at Customer has also moved to X8. If this was, if this seminar was next week, the week after, there'd be a few more announcements that I could talk about. I've just spent quite a bit of time talking about Exadata X8M from a on-prem point of view. You can assume, and I don't think it's hidden knowledge, but being able to move that into cloud workloads. So the X8M, the Rocky piece, moving into Cloud at Customer, moving into cloud service. We didn't release at the same time because we moved from Zen to KVM, so there's tooling that needs to be worked on from a cloud perspective. But X8M will be moving into Cloud at Customer, Exacloud service. Can't really give you dates. I could say this financial year, but that doesn't help you at all because we've only just moved into this financial year. Some of the, let me just bring it up. So you'll notice that with the Exadata cloud variants of Exadata, they actually have a few more cores from a database node perspective and storage cell, because we mandate encryption as part of it. So we use TDE. So therefore we give a few more cores on the storage. Autonomous is another piece that is really coming through and is the combination of what we're doing from an Exadata point of view, being able to automate the underlying infrastructure and the pieces around the database is something that from an autonomous workload, we're really seeing the benefits come through. Has everybody got their free cloud piece? I just signed up the other day for my free cloud, and that includes the autonomous database, and knowing that sitting underneath that autonomous database is an Exadata, and being able to use the benefits of Exadata under autonomous is something that I thought was incredible. It's an amazing piece of work that we're basically, we're giving away for free. So please pick up that, go to oracle.com cloud free. Yeah, in terms of what's coming up, let's see what I've got here. I'm hoping that, how about I just move it onto this slide so we can then talk. So we've got Exadata software coming out. Obviously, we're releasing sustaining releases and the patches every month to pick up the latest security fixes and bug fixes. We will be releasing our Exadata 20.1 software very soon. I was hoping to have that announcement for you today, but they're still in testing. So that's coming up fairly soon. Kind of like our 19.3, let me see where that slide is. Back in the 19 software, we had obviously additional software that enabled workloads for the database and being able to pick up a lot of those new autonomous features. We continue pushing new features into that. So the Exadata software 20.1 we'll add a few more of those. Keep an eye on the Oracle documentation, what's new. We'll keep an eye on the Oracle blog, the Exadata blog for when we release that. Should be around the corner. We have some announcements coming up around the Exadata Cloud at Customer and where that's going. That's some exciting news from that front. But again, the timing means that I can't quite talk about it at the moment. But keep an eye on oracle.com for that. Exadata itself, we continue looking at new features and new hardware. As I mentioned, we've over the space of the last 12 years now, increased our the features of what we have and what we're providing. So persistent memory was one of those new pieces coming in with X8M that's just going to continue to grow, and the use cases from that will continue. The Rocky piece, we're now on a converged Ethernet platform, so you'll see that as we go forward, we have additional benefits coming in from that perspective. Our CPU choices, we continue to look at that. So you can kind of use this slide as a kind of a forecaster of where we're going. And the additional software features will continue, grabbing whatever we can in terms of enabling our Oracle database workload. Autonomous databases is something that underlying that we have the Exadata platform. So what, from an Exadata point of view, can we use to enable the Oracle autonomous database? What features in the autonomous database are really reliant on the underlying hardware, and will continue outputting for Exadata customers those autonomous features. So that's another piece of piece of work that we're making sure that is coming through on Exadata. But yeah, in terms of roadmap, there's not much unfortunately I can talk about. Yeah, I could probably go in a little more detail if we're standing over a beer, but this is kind of where we are at the moment. So I hope that's been good. I'm at the 45-minute slot, so yeah, if you have any comments or questions, and as I mentioned, those three things, if you want to hit me up on one thing you like, one thing you don't like, and one thing you want to know more about, it'll help me, tailor these kind of presentations or come up with new presentations or new blog posts about things. Reinhold, any other questions, sir?
Currently not. So concerning what's coming next, we'll get some smooth improvements on nearly every layer, but there will be no big bang or so.
Well, I'm not saying that. I mean, we continue looking for the ideal hardware, and we continue working on software features that really enable that hardware. So, the Rocky release was a very big release, and it enabled us to really push through. I don't have that slide, but if you have a look at the history of Exadata over time, the IOPS they were starting to actually flatten out. So moving to Rocky and persistent memory really shot us back into that increased performance and benefit. So we continue to strive and continue to work towards that goal. And back at the first slide that I presented, the kind of three-pronged vision, making sure each of those vision statements are being worked on actively. And the engineering team are very active chasing those three goals. Yeah.
Are there more questions from the audience?
Feels weird me being the only one on video, but that's all right.
So currently there are no more.
Okay.
No more questions. So thank you, Gavin, for your presentation, and see you hopefully in Nuremberg.
Yes, hopefully see you in
November.
person next time.
Yeah.
If I'm allowed out the country.
Okay. Thanks.
Okay, thank you.